In this video, we'll cover the problem calculator. So for this problem, we're building something that resembles an old school calculator. You can only press one key at a time, and you'll kind of see an output based on that. So for example, if you press 5, you will see 5. If you press a plus, you'll have the plus. If you press 7, it'll store the 7. You press equals, and it's going to return the result of 5 plus 7, which is 12. And with these calculators, it usually stores that result. So if after the equals you see 12 on your screen, then you press a minus and then a 3 and then an equals, you would see 12 minus 3, which is 9. And in our case, there are a few characters we can press. There's 0 through 9, which are our digits. Note that they come in as strings here. There's a plus, a minus, and an equals. Those do what you'd expect. Plus says, hey, we're going to be adding. Minus says, hey, we're going to be subtracting. Equals says, okay, now compute the result of the data we've stored. And then we have this C symbol that clears everything. Our job is to write a key press function that takes in a key and returns what would appear on the calculator's screen. So the key is really these cases when we're trying to evaluate some sort of operation. Okay, I believe that should be the key of what we're doing. I think there's one more thing I wanted to mention that I am not remembering right now, but I'm sure it'll come up. Okay, first thing to realize here is that we need to store state. This key press method needs to know about things that happened in the past. In order to store state, whenever you're trying to solve any problem really, you need to use a class, because the class can have properties on the class that store the state that will persist in between multiple times where you call this method. So we know we want to write a calculator class. So I'll just go ahead and do that. And we know we're going to have a method called keyPress that's going to take in a key. Now, looks like I have GitHub Copilot on. That is not what we want right now. Let's turn that off. Here. Disable reload required. Okay. Hopefully we will not get it writing all of our code now. Okay, I think we're good. All right, so here we know that we are going to have some behavior based on what the key is. So a nice statement for that is going to be a switch statement if you haven't used that before. Basically what it does is you can write a bunch of cases. Like you can say case h console.log h and then break. And what this says is like if the key is an h, then handle it by doing this. But if the key is a B, handle it by saying, I don't know, boat here. And then you can break. And basically you can just say like do different behavior based on what the key is. That's what this switch statement does. And the break is key because otherwise it's going to kind of, once it does this statement, it's going to go on and check the other statements. But usually you only want it to do the behavior of one of the statements. So you always need these breaks. Now, what are the options here? Well, we've got these right here. So what I will do is I will grab, I'm going to make some constants for each of these. So I'm going to have add, which is going to be plus. I'll have subtract, which is going to be a minus. We'll have evaluate. I'm going to call it evaluate because really when we hit equals, the action we want to take is we want to evaluate whatever computation we have put in so far. And then we'll have clear, which is a C. Okay, so we'll have some cases. We'll have case add. We'll do some stuff and we'll break. We'll have case subtract. We'll do some stuff and we'll break. Okay, same thing for evaluate. Do some stuff and break. Case clear. Do some stuff and then break. And then we'll have our default case, which is just when none of these are true, what do we do? And this should be a digit string, hopefully. So right here should be digit string. Okay, great. So now we kind of have this set up for what we want to do. Now we have to actually enable our functionality. So there are really three key pieces of data that we need to store. When we're on this equal sign, we need to know what was the first number, what was the operation, what was the second number. So what I'm going to do is I'm going to store three pieces of data in state of our class. So we'll come here, we'll have our constructor, and it's going to do this dot, we'll call it num before operation, which will be null, we'll have the operation, which will be null, and then we'll have a num after operation here. And we're going to set that to be null as well. So what do we want to do here? Let's see. Okay, so I'm going to leave a comment here. We'll say validate that this is a digit string. For now, we're going to ignore that. We're going to assume that we have a string that is purely digits. Then when we get our first number, we want to update the num before operation. But if we have an operation, then we want to update the num after operation. So we're going to have some logic. So I'm going to write a function called update num, and I'm going to pass in the key here. Now we're going to have update num. It's going to take in the key. If these two guys are both not null, then we know we should update. For example, imagine that we just press 5, and then we were kind of like pressing a new number. By the way, one thing I should mention is numbers like 57 are not supported here. We're just going 0 through 9. So if I press another number, so say I just press 5 and then I press 10, or I guess 10 is not a valid number. Say I just press 5 and then I press 3. All we want to do in that case is we should overwrite this dot num before operation. Initially it was nothing, then it became 5. Now we just overwrite it to 3. The only case where we should actually update num after operation is when num before operation is not null and the operation is not null, because then we've pressed something like 5 and a plus. So what we can do here is we can say if this dot num before operation is not null and this dot operation is not null, then we should set this right here. So we'll say this dot num after operation equals, maybe we'll use some curly braces because this is getting pretty long. We'll say this dot num after operation equals key. Now remember that our key actually is a string and we want a number so that we can actually do our computation. So we're going to parse int here. And then we can just return here because we're done. We've updated our number. Otherwise, we know that we should be overwriting the first number, or I guess writing it for the first time. So we'll say this dot num before operation equals parse int key, and then we can return, but we don't need to actually write that. And so that should handle the behavior that we're looking for here. Okay, now imagine that we had updated some numbers, added some data, done something like that, and then someone presses the clear button. Well, we want to go all the way back to this right here. So we could do something like copy this and paste it here. That's not very good. What would be better is to make a function. In the case of this class, we can make a method that does these three things, and we would call it here, and we could also call it here. So I'm going to do that. I'm going to make a function. We'll call it reset to default. It's a function, but it's also a method on this class. And all it does is it just sets these three properties to be null. So in the constructor, I'm going to call this dot reset to default. So we set these three properties, but in a more reusable way. And then when someone says clear, we just say, okay, reset to default, and that's all we have to do. We don't have to do anything else. Okay, so this handles when someone presses a number. It handles when they press clear. When they press an operation, these are not too bad either. Let's see. I believe, Yeah, I think the way we can do this is we can say, if somebody says add, I'm just going to set the operation to be add. And if somebody says subtract, then I'm going to say set the operation to be subtract. I have tried to figure out if there's a way to because you can see the logic is the same. We take whatever this is here, the key, and then we just set operation to be equal to that. I tried to find a way to do it in one, like some sort of or statement or something, but that did not seem to work. So I'm going with this. It's not a big deal. It's not too much repeated code. Okay, great. So now we have most of the setup logic done. So somebody presses 5. We're going to set num before operation to be 5. Then somebody presses add. We're going to set, all right, the operation is add. Then somebody presses 7. We're going to say num after operation is 7. Now someone clicks equals, which is what our evaluate is, and now we need to make that work. So how are we going to do this? First thing we should do, well, first of all, there's going to be some logic in here. So let's make another function. We'll do evaluate result here. We're going to call that. So we'll come up here. We'll have a evaluate result function. First thing we have to do is make sure that we can evaluate the result. So we'll do can evaluate result equals. Well, all three of our properties need to be defined. So what we can do is we can say, all right, this guy should not be null, and the operation should not be null, and the number after the operation should also not be null. Hopefully this will format. Yeah, there we go. And then what we can say right here is if we cannot evaluate the result, just immediately return null. We don't need to do anything. And I'm going to leave a comment here that will say handle null return value. Okay. At this point, now we can assume that we have a valid operation. Then we can say we need to execute something based on our operation. So we'll say if the operation, or this dot operation is equal to add, we're going to return the number before the operation plus the number after the operation. And then we can say if the operation is subtract, then we're going to return the same thing. Actually, not exactly the same thing. It's going to be the number before minus the number after. And I believe that should be all. There theoretically is a case that comes here, but this should never actually be triggered because this would happen when this dot operation is not null and it's not add and it's not subtract. But we initialize it to null and we only ever set it to add or to subtract, so it should never be possible that it is anything else. Okay, so now we can come back here and figure out what are we going to do with our evaluate result output. Well, first thing is we want to store in a variable, so we'll do evaluation result so that we can do some stuff with it. Now remember that it can be null, so first thing we'll do is we'll just say, all right, if it's null, just return null. We don't want to do anything. Something went wrong. We probably shouldn't have been doing an operation yet. Let's just, stay exactly where we are. But if we have something that is not null, meaning we get to this line, in the end, we want to be returning our evaluation result because remember, the key press returns what would appear on the screen. So what would appear on the screen would be the evaluation result. So at this point, you can see we actually don't need the break. We can get rid of that. But we need to do some stuff in between here. Remember, the way a calculator works is like, or I guess we can look at the example from the beginning. So we go 5 plus 7 equals, we get 12. But then we can do a minus and then a 3 and then get 9. So this 12 needs to be stored. In fact, it's stored as the number before the operation. So what we're going to do is we will come here and we will say this dot number before operation is equal to evaluation result, so that if anything happens in the future, we should actually be able to use it. If anyone presses future operations and tries to do something else, we will have stored the evaluation result right here. Okay, for the most part, I believe this should cover what we need to do. The one other thing is that we need to validate that we actually have a digit string. So let's actually check, do the tests handle this? Yes, they do. Okay. So the easiest way to do this is using a regular expression. So I will show you how to do that. Let's define a generic function up here that will say is digit string, takes in some string, and does something. Note that I'm writing this outside of the class because all of these methods are specific to what our class is trying to do. But this is digit string is more generic. Someone might use this who is not working on this calculator class. So what we'll do here is we'll say if not is digit string, our key, then we're going to say, well, console.error, we'll just say error, you have provided an invalid input, please enter 0 through 9, 0 through 9, what else? Plus, minus, equals, or C. And that can be our message, and then we'll return so that we don't actually do anything. Okay, now to write this isDigit string function, this is where we're going to use a regular expression. This one I'm just going to copy in from the solution because I don't remember it off the top of my head. So we can grab this here. And what we'll do is we will say return string dot match this pattern. I actually not use this in a little bit. So I'm going to cross-reference the solution real quick just to make sure. Yeah, okay, we're basically doing the same thing. The key is that they make it a string first. So I guess we can say, we'll do key.toString here. Just in case it's not a string, we're going to make it a string. And then we'll see if it's a digit string. I guess we can make a variable for this just so it's a little less verbose right here. So we can do key as string right here, and then we'll see if that is a string that exclusively contains digits. So this here, I'm not going to spend too long on this because it kind of is a separate thing, but regular expressions can look at a string and tell you if it matches a certain pattern. So this right here is saying you have characters that are 0 through 9, and then star means you can have any number of them, 0 or more. So you can have a bunch of characters that are 0 through 9. That's what this is saying here. Okay, and if we don't have that, we're going to print out an error. All right. I believe that is everything that we wanted to do in this function. So let me go ahead and see if we can run this and get our desired output. I'm sure there will be some bugs. Okay, so we've got expected 12, 12, 2, 2, 18, 18, 11, 11, 18, 18, 11, 11, and then null, null. Okay, great. Looks like we are performing the behavior that we are hoping to. All right, well, that's all for this video, and thank you for watching.